Welcome to the podcast, Naming Branched Alkanes. The learning target in this particular podcast is this. You should be able to draw and name branched alkanes. Branched alkanes are different from the alkanes you've already seen in that they have one side chain. If you look at this alkane here, it differs from the previous alkanes that you've seen in that it has this branch. This is the branch of our alkane. Branches are named by taking the alkane names that you should already know and replacing the A and E ending with a YL ending. So for example, a single carbon alkane is methane. When it becomes a single carbon branch, we call it methyl. Likewise, a two-carbon alkane is ethane. When you have a two-carbon branch, it becomes ethyl. Likewise, propane is a three-carbon branch or three-carbon alkane. When it becomes a branch, it's propyl. And that goes on with the other alkane names that you already know. So let's take a look at the rules for naming branched alkanes. Here is the first thing you need to be able to do. You need to find the longest continuous chain in your alkane. This longest continuous chain gives you the alkane root name. For this branched alkane, I think you can see pretty clearly that this root has 1, 2, 3, 4, 5, 6, 7. This particular branched alkane has a root that is 7 carbons long, and that means its root name is heptane. We're not finished, but that's the first step in naming this branched alkane. The next step in naming our branched alkanes is to number the carbons in the carbon chain in both directions. So let's do that. If we start here, this would be carbon 1, this would be 2, this would be 3, 4, 5, 6, and 7. If we numbered it the other way, this would be 1, this would be 2, this would be 3, 4, 5, 6, 7. Our rule says we should identify the position of the branched chain by choosing the carbon with the lower number. Well, here's our branch. And you'll notice if we numbered it from left to right, this branch would be on carbon 3. If we numbered it from right to left, this branch would be on carbon 5. Clearly, 3 is the smaller number. So we would choose the number 3 to indicate the position on this root where this branch is coming off. And since this branch consists of one carbon, it is a methyl group. With a dash in between the 3 and the word methyl. The name for this branched alkane, therefore, would be 3-methyl heptane. And note that the name has no gaps in it and that there is a dash right here between the number and the name. The heptane part of the name gives you the root. The 3 tells you what carbon the branch comes off. And the word methyl tells you the kind of branch that it is. 3-methylheptane. Sometimes alkanes have more than one branch. If the branch is of the same kind, we use a prefix to indicate the number of branches. Let's take a look. We have here our root, and I notice that there is a methyl here and a methyl here. We have the same kind of branch. Let's go through the process of naming this alkane. So let's find the name of the root. This carbon has 1, 2, 3, 4, 5, 6, 7. So the root name here is also heptane. And I notice that we have a methyl group here and a methyl group here. Well, that's 2 methyls, so that's dimethyl. And we need to find out the position of these methyl groups on our root by numbering our carbons. So if we number from left to right, this is 1, 2, 3, 4, 5, 6, 7. If we number the other way, it's 1, 2, 3, 4, 5, 6, 7. So if we indicate the position of these methyl groups from left to right, we notice that it's on carbons 3 and 5. And if we go from the right to the left, they are also on carbons 3 and 5. So this is an example where it doesn't matter in which direction you numbered it. So if we put all of this together into one name, the name of this particular branched alkane would be 3, 5 dimethyl heptane. Let's do another. We have a branch. This branch consists of 2 carbons. That would make it an ethyl group. We have to find out what carbon it's off of. So this is 1, 2, 3, 4, 5, 6, 7, 8, if we measure in that direction. If we measure in this direction, it's 1, 2, 3, 4, 5, 6, 7, 8. So our ethyl group is off of carbon 4 if we count from the left to the right, and it's off of carbon 5 if we count from the right to the left. Clearly 4 is left 5. So this ethyl is off of the 4th carbon, so this would be 4-ethyl. And clearly our root name is going to be octane. So if we put all of this together, the name of this particular branched alkane would be 4-ethyl octane. Let's try another one. And in this instance, we have two branches. We have this branch here, which is a methyl group. And we have this branch here, which is an ethyl group. And the new piece of information here is that when we put these branches into the name, we put them in alphabetical order. And clearly E comes before M. So the ethyl will precede the methyl in the name. But we still have to indicate what carbons these are off. So let's number our carbons. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So if we go from left to right, I notice that my branches are off of carbons 3 and 5. If I go from right to left, my branches are off of 4 and 6. Clearly, 3 and 5 are smaller. So we have a 3-methyl and we have a 5-ethyl. And our carbon chain is 8 carbons long, making it an octane again. So if we put all of these together with this one first, because alphabetically E comes before M, the name for this branched alkane would be 5-ethyl methyl octane. One great big long word with numbers and dashes. Remember that the learning target states that you should also be able to draw the alkane from the name. So let's do one. This is 4-ethyl 3,5-dimethyl nonane. I like to start with the root. Nonane is an alkane that is 9 carbons long. So 1, 2, I like to leave room for the H's, 3, 4, 5, 6, 7, 8, 9. There's my root. 4-ethyl tells me that off the 4th carbon I have an ethyl group. So 1, 2, 3, 4. I'm going to put an ethyl group. Ethyl has 2 carbons. 3,5-dimethyl. This means I have a methyl group off of carbon 3 and a methyl group off of carbon 5. So 1, 2, 3, I put a methyl group off of carbon 5. 1, 2, 3, 4, 5, I put another methyl group. So I have 4-ethyl 3,5-dimethyl. So I have the skeleton of my branched alkane. All I need to do now is put in my hydrogens. And the thing to remember about hydrogens in alkanes is that all carbons have to have 4 bonds. So if we look on this end, this carbon is already bonded to this carbon, so there are 3 more bonds we have to take care of. That means that there will be 3 carbons on this ending hydrogen. This carbon has 2 bonds. It has a bond to the previous carbon and a bond to the following carbon. We have 2 more bonds we have to take care of. So we're going to write H2, and that will be true for this carbon as well, and this carbon as well. Now this carbon already has 3 bonds on it. So there's only 1 more bond we have to take care of, so I'm only going to put 1 H there. Same is true for this carbon here. I didn't leave much room for that hydrogen, did I? This carbon has 2. We need 2 more hydrogens to bond onto there. This one is on the end. This one needs 3 more. This one needs 3 more. All the ending ones need 3. This needs 3, and this one is an ending one. This will need 3. Let me see, this carbon has 2 bonds already, so we're going to need 2 hydrogens here. This carbon has 3, so we want only 1 more hydrogen there. So what we've done here is taken the name 4-ethyl-3,5-dimethylnonane, and we've systematically written the structural formula for this branched alkane. There is one caution that you need to be aware of when you're working with branched alkanes, or non-branched alkanes for that matter. Bending a chain does not change it. Let's take a look at an example of this. This clearly is pentane, 1, 2, 3, 4, 5 carbons long. This is pentane. Some people, when they look at this, would think it's a branched alkane because this part of the formula is pointing downwards, but if you look carefully, you'll notice that it's not really a branch. All we've done is take these 2 carbons and write them down here. We've bent the chain, so to speak. That does not change the alkane. This is not a branched alkane. This too is simply pentane. All we did was bend the chain. One of the things I like to do to make sure that I don't make a mistake is I can tell when it's just a bend if I can take my pen or pencil and without lifting it from the paper, see how long I can go and to make the longest chain without lifting up my pen or pencil. And here I think you can see I did not lift my pen, and I was able to have an alkane that was 5 carbons long, making this one the same as this one. So let's take a look at one that's a little more complicated, and let's see if we can correctly name this alkane. Well, as I look at this, this just looks like a bend. This could be written over here, and well, this goes straight, but as I look at this one, it appears to me as though I could make my longest chain by doing this. I could come down, turn, come down here, and I come down over here, and I notice I did not lift my pen. So my root name here would be 1, 2, 3, 4, 5, 6, 7. My root name would be heptane. This is my branch. It's an ethyl group. And if I count my carbons, if I come this way, it's 1, 2, 3, 4. It's the fourth carbon if I start from the top and work down, and it's 1, 2, 3. It's my fourth carbon if I work my way up. So either way I do it, this will be 4-ethyl. So the name for this particular alkane is 4-ethyl heptane. If you go to your packet, you can practice these skills on pages 23 and 24.